Hey everyone, and welcome to This Explainer. I am absolutely thrilled you're tuning in today because we've got a fantastic, super practical session lined up for you. We're going to bridge that massive gap between networking theory and actual hands-on application. If you've ever found yourself just staring at diagrams of networks, wondering how the heck they actually get wired up and configured in the real world, well, you're in the exact right place. Because today, we are going to build a fully functional peer-to-peer network right from scratch. But first, let's talk about why we're even doing this. You know, so often learning about computer networks just gets totally trapped in the theoretical. It becomes super mark-oriented, right? We're just memorizing OSI models and routing protocols to pass a test. But here's the thing. Knowing the theory just isn't enough anymore. You really need practical, hands-on knowledge to crack those network-based interviews, to tackle analytical exams like GATE, and to genuinely succeed out in the field. We need to be knowledge-oriented. And that means we gotta get our hands dirty. Well, virtually at least. Okay, let's dive right into this. Here is our roadmap for today. Step 1, we'll meet Packet Tracer. Step 2, we check out the workspace. Step 3, we make our physical connections. Step 4, IP configuration. And finally, Step 5, verification. Starting off with Section 1, meet Packet Tracer, the ultimate sandbox. So, we need a way to build networks without dropping thousands of dollars on expensive hardware, right? Well, Cisco, literally the absolute leaders in the networking space, gives us exactly that with Cisco Packet Tracer. It's this wildly innovative and powerful networking simulation tool. I want you to think of it as your ultimate, completely risk-free sandbox. It's perfectly designed for practice, discovery, and troubleshooting. It actually lets us simulate the behavior of real-world networks with astonishing accuracy, all from the comfort of our own screens. And honestly, what's even better is just how insanely accessible it is. To get your hands on this, you literally just open your browser and head over to netacad.com. The enrollment is completely free. And when you sign up, not only do you get to download the latest version of the software, but you also score access to a super helpful 10-hour self-paced course to help you get the hang of things. You just pop in your name and email, and boom, you've got an industry-standard simulation tool ready to go.
Moving right along to Section 2, the workspace, your network toolkit.
Now, once you open up your brand new workspace, you'll see this big blank canvas. This is our playground. It's where we build. Down at the bottom, you've got an incredible variety of devices right at your fingertips. We're talking routers, different switches like the super popular Cisco 2960, end devices like desktop PCs and laptops, wireless gear, security firewalls, and of course, a whole drawer full of cables. We're definitely going to be exploring a lot of these later on, but for today's simple peer-to-peer build, we're just going to grab 2 standard desktop computers and pop them right onto our blank workspace.
All right, Section 3, physical connections, wiring the network.
Okay, with our 2 computers chilling on the workspace, we click on the Connections tab. Suddenly, we see all these options, like copper straight-through cables and crossover cables. Now, this is an absolutely crucial point for any network engineer. Which one do we actually choose? Well, a straight-through cable is used to connect 2 different types of devices, like if we were connecting a computer to a switch. But a crossover cable? That's used to connect 2 devices of the same kind. Since we are connecting 2 identical desktop computers directly to each other today, we absolutely must use the Ethernet crossover cable.
So, here's exactly how we make it happen. We've placed our 2 desktops. Next, we select that Ethernet crossover cable. Then, we click right on the first PC. A little menu pops up showing the physical ports on the back of the computer. We're going to ignore the serial ports for now and specifically click on the fast Ethernet port. Then, we literally just drag the cable over to the second PC, click it, and plug the other end straight into its fast Ethernet port. I want you to imagine actually holding a cable and plugging it into the back of a physical PC tower until you hear that little click. That is exactly what we've just simulated. Let's jump to Section 4, IP configuration, logical addressing. Now, what's really interesting here is that even though we've plugged in the physical cables, right now these machines actually can't talk to each other. Why? Because they don't have logical addresses yet. They basically don't know who they are. To fix this, we click on our first computer in Packet Tracer and navigate over to its desktop tab. From there, we open up the IP configuration menu. We are going to go ahead and boldly assign this first computer a very specific IP address, 10.10.10.1. We'll just let the software automatically fill in the default subnet mask for us. We're keeping our focus strictly on the IP address today. So now this first computer officially has an identity.
Next up, we do the exact same thing for the second computer. We click on it, go to desktop, then IP configuration, and we're going to give it the IP address 10.10.10.2. So the absolute key takeaway here is that both computers now have their own unique logical identities on our little two-node network. 10.10.10.1 is wired directly to 10.10.10.2.
And finally, Section 5, verification, proving the connection. All right, the stage is perfectly set. We've got our hardware, our cabling, and our logical addressing all locked in. Now it is time for the ultimate test to prove that this connection actually works. So we open up the command prompt on our first computer. That's the 10.10.10.1 machine. The very first thing we want to do is verify our own settings. We do this by typing the command ipconfig /all. When you hit enter, the simulation acts exactly like a real-world PC. It spits out our IP configuration details, and it also reveals our physical MAC address. Now, when you run that command, you're going to see a 48-bit MAC address. But I want you to look really closely at the formatting here. In a standard Windows environment, MAC addresses are typically separated by hyphens. But Cisco actually uses a totally different notation. In the Cisco packet tracer simulation, you're going to see those 48-bit addresses separated by dots instead. It's a small detail, sure, but knowing the difference between Windows and Cisco formatting is a fantastic little nugget of practical knowledge to have out in the field. Okay, we've successfully verified who we are. Now let's reach out to our neighbor. Still sitting at the command prompt of our first computer, we're going to type out the ultimate test command, ping 10.10.10.2, and we hit enter. What's actually happening right now is our first computer is sending out 4 distinct packets of data across that crossover cable, basically asking the second computer, hey, are you there? Can you hear me? And wow, look at these results. The command prompt replies with exactly what we want to see. 4 packets sent, 4 packets received, 0% loss. Our second computer received every single one of those 4 packets and sent 4 acknowledgements right back to us. We have perfect, flawless communication. How awesome is that? This right here is exactly why Packet Tracer is so powerful. It gives you the absolute exact feel and output of working on physical network devices. We literally just built a fully functional network, both conceptually and practically. So there you have it. You have successfully bridged the gap between theory and practice today. You've simulated a 2-node peer-to-peer network with complete success and absolutely 0 packet loss. But remember, this is just the very beginning of what this sandbox can do. With all those routers, switches, wireless access points, and firewalls just waiting in that workspace toolbar, what complex network are you going to build next? I highly encourage you to grab the software, start experimenting, and take your practical networking skills to the next level. Thank you so much for joining me on this explainer, and keep learning.